This is the second video for testing for convergence or divergence of our series. We have our series going from n equals to 6 to infinity of 1 over n times the square root of the natural log of 6n. I'd encourage you to pause the video before you watch the rest of this. Try to at least if you don't want to work it out, I would recommend working it out, but if you don't want to work it out, you can at least think about what test might be useful, because sometimes that's the hardest part. Oftentimes it is. So let's go ahead and start with the divergence test. That's the best thing. Now you can do this in your head, but I'll just write it out because, some people want the written out version, so this is good to do it. So this is the square root of the natural log of 6n. So as we go to infinity, notice that we have no n's on the top. It's just 1. So it's a constant. It's not going to change. Nothing happens on the top. In the bottom, we have the variable. It's changing. That's why it's a variable. And this is going to get infinitely large. And this over here is also going to get larger and larger. So that tells you that the denominator in general is going to get larger and larger, which means that if we get larger and larger in the denominator, we're essentially going to get 0. Since the numerator is just 1, it's not changing, nothing happens. So this is inconclusive. The divergence test doesn't help us here. Next thing that we want to do is go on and check. So telescoping series, no. Geometric, no. Harmonic, you can go through these fast. No. Divergence test, no. Now integral test. Now this is interesting. Don't just say no and move on because you think this is a hard integration. This is interesting. Okay, let's think. We have this 1 over n here. And natural logs, when you take the derivative of a natural log, you get 1 over something. You get 1 over, if it's just natural log of x, you get 1 over x. If it's natural log of like 5x, you get 1 over 5x. But then you have to multiply by 5, and so the 5's cancel, and so you still get 1 over x. That's interesting, because if you do that, if you decide to use the integration for this, integration method, so 1 over n times the square root of the natural log of 6n, what I would do is I would set my u. So I'm just gonna test this out. It's just work. It's just a work. It's just some work. So du equals natural log of 6n. If I take the du of this, if I take the derivative of this du by dx, if you want to write this like this, it would just be 1 over 6n, and then the chain rule, so multiply by 6. Notice that these n's here, they cancel. So that gets you to du, and I'll multiply the dx on both sides, gets you to du equals 1 by n dx. We have that here. And we also have I should have said n instead of x here, so that's why I was confused. So du, so this is dn, du is 1, okay, that's what I wanted to write, okay? So this we have, and we're supposed to add a dn here. And so yeah, this is gonna work. What I'll do is I won't use the n's here. Instead of using the n's, I'll use x's for the integration. So instead of 1 over n, I'll write 1 over x times the square root of the natural log of 6n. This is 6x. This is not gonna make a difference. Okay, so let's see. What I'll do is I'm going to take this, I'm going to move it down here, and what I'll do is I'll integrate this from 1 to, rather 6, because that's where we start, so 6. Now instead of writing infinity here, I'm going to write b here, and then take the limit as b approaches to infinity, because that's an improper integral, and then dx. Okay. What's this going to get you to? Well, again, let's just do the same thing we did before, and I'll do it quicker here. U is the natural log of 6x, so du is just 1 over x dx. Let's do that. Let's replace all of this stuff. Now limit as b approaches to infinity. What I'll do is I'll actually just not write anything here for now. Just leave it blank, because we are still in the u world, and we're not in the x world. I don't want to convert back and forth. So I'm just going to leave it in the u world, not worry about any of this business here, and just say 1 over, so 1 over x dx is du. So this stuff is this stuff. So that's du. And then we have 1 over the square root of the natural log of 6x, which is just the square root of u. Of course, we have to have some bounds of integration here. I'm not going to worry about that for now. Just going to leave it blank. Just like do that if you want to. That's what I'll do here for this problem. You could choose to do something else if you want, but yeah, I'll do this. I'm just going to erase this and rewrite this as u raised to the negative 1/2 because it's the same thing. And then I'll write the integral. So u to the negative 1/2 is basically u to the negative 1/2. So if we integrate that, u to the negative 1/2 plus 1 over negative 1/2 plus 1. Negative 1/2 plus 1 is going to get you to that 1/2. And then divide that by 1/2. Or we could just multiply by 2. So it's just 2 square root u, basically, okay? 2 square u. You can check that again. Let me do that here. I feel like I rushed that. So u to the negative 1/2 du is u raised to the negative 1/2 plus 1 over negative 1/2 plus 1, which is u raised to negative 1/2 plus 1 here is 1/2 and then over 1/2, which is the square root of u over 1/2 or 2 square root u. Just some integration review for those who needed that. There you go. So this is 2 square root u. Instead of writing the square root u, I'll just replace it. Whoops, that's not what I wanted. I'll just replace this with the natural log of 6x. That's what u is here. The natural log of 6x. Okay, so that's essentially what we get, right? So let me go ahead and scroll down a little. That's what we get as a result of integrating this here. So we end up with a limit as b approaches to infinity of, so 2 times the square root of the natural log of 6x. Is that what we got? Yep, that's what we got as a result of this. And then we can go back to our b and our 6, so 6 to b, okay? And then, so that's what we get. So if we rewrite this, we can get the limit as b approaches to infinity. So plug in b into where we have our x's here. So it's just going to be 2 times the square root of the natural log of 6b minus 2 times the square root of the natural log of 36. This doesn't matter, okay? This doesn't matter at all. We could have just not even did this part and just said that, okay, it's going to be some number. But yeah, we can write it out. It's fine. This is going to get you to, so this is some finite number. This is what we have to worry about now. This here is going to get infinitely large, and then this whole thing is getting infinitely large. This entire thing is just going to be infinity. So we end up with, without a limit, we end up with infinity minus 2 times the square root of the natural log of 36, which is just infinity. This means that we are divergent. We have a divergent integral, improper integral, which tells us that this right here is also divergent by the integral test. Now, I didn't include it in this video, but before using the integral test, remember, there's 3 conditions you have to meet. That means the 3 conditions are that this is continuous, positive, and decreasing. It is continuous from 6 to infinity. It is positive, and it is decreasing because this is getting larger and larger, and as we get larger and larger, it's going to get smaller. The whole values are getting smaller and smaller. Hopefully you can check that. Just check P, C, D. Positive, continuous, decreasing. Checking these will help you determine if you can use the integral test or not. And so that's what you got to check. And so this proves that we are divergent. And that's it.